Right. Got my non-working 64 here, which seems to be very flaky. So I'm just going to run a quick test. I was just trying to do diagnostics. This is a follow-up on the previous one. I say, unlike some of the other guys out there who can do a lot of work with repairing 64s, I'm just coming at it pretty much with very little electronics experience, etc. So I'm just trying to learn as I go to actually fix this. To that end, I thought I'd give another go before I go to bed tonight, as it's 9:35 at the moment, and I just thought I just want another look. So I was having a look at the diagnostics cartridge again, and just what I was going to look at is one of the tests, which is this Dr. 64, which is very much in German. I did try and find an English version of this manual, but haven't. I've had a little test already, but I was just going to go through one of the things I found. So it's just, oops, let me just turn the volume down from the 64 coming. So if we turn this on, so we should get the start of the testing. So 64K RAM. So the RAM for all the tests I've been running seems to be okay. Although one of the tests seems to hang on the RAM, so never know, it might not be too bad. But a lot of the stuff seems to be okay. So it says keyboard bad, but obviously I'm not using the keyboard adapter. And then it says as it was below there, that way, it said the cassette was bad, serial was bad, user port bad. So one thing is if we just let it cycle through, so up to the basic again, kernel again, timers, interrupt. I had this running a couple of times, so got to about test 4 when I was testing it, and then we got to a point where got to the serial bus. Okay, so I think that's what it's actually done here. So it's probably got a continuous sound running here. Let's just check. Oh, nothing. Okay, so it seems to have hung on the serial bus. Let's just reset that. Let's just try again. Yeah. On this manual here, there's a whole bunch of tests it's running. So as it goes for 64K RAM, so got this bit here. Oh, I can't highlight it really. But so 64K RAM. Does a basic ROM, do the kernel ROM test, timer test. So that's again, that's on those two CI chips. So the which is in U1 and U2 here. So that's what's that, number 7? Not quite sure what that's doing, but I'll get down to the serial bus. Again, we seem to have stopped at the serial bus again. So it's just a second time around. Let's just try that once more. And if you have a look at the, so we've got interrupt tests, so non-maskable interrupts and the IRQ, which is what it says here. And I guess that's the interrupt tests. So interrupt seems to be okay, and that's talking about what was it? It seems to involve U1, U2, and U7. Well, there we go, and we've hung on the serial bus again. So the test cassette fails, which is 10. As per the previous video, it does actually start. But if we look at the serial bus test here, as we can see here, it's talking about U1 defect, U2 defect, or U8 defect. What was U8? Bear me 1 second, I just need to pause this. Okay, back again. So according to what we have over here, where's it gone? Oops. So the serial bus, let's just start that again. So the serial bus seems to relate to U1, U2. So we've got the two CIAs here. And it also seems to relate to U8, which, sorry, let's take this a bit. That seems to be, U8 seems to be this chip here, which says 7707 and then 1684. Okay, that's actually just run through that without stopping. Let's just wait for it to go through. So if there's an issue with U1, U2 or U8, which is this one, according to the service manual, it says here that U8 is either 7406 or 7416, which is a bit odd. So that says 7707. Looking at the solder on this does seem to be the original chip. So for whatever reason, for the 250407, which is what this is, it seems to have a slightly different chip here. So what's so don't know what ODA means in German, although it says U2 defect. I'm not sure if ODA's possible defect. Signaling, and I do not know what the rest of this means. But very much that does seem to get to the serial port and stop. Let's just go one more time. So defects in U1, U2 or defect in U8. Like I say, it's a bit weird that it seems to say 7416, but as I said, it is a 7707. Some kind of timer chip. Okay, we're cycling through that again. That's a little bit bizarre. Let me just pause this for one moment. Okay, back again. Right, so looking at the circuit diagrams about that, let's just start that again. This 7707 here, let's come back to this. I was just reading up some stuff. This MOS 7707 seems to be a replacement for a 7406 chip, but it seems like a lot of the MOS stuff worse. This chip talks to the outside world as well as some of the stuff of the CIA. Things go falling apart. Oops, let's just plonk that there for a second. Should stop watching. Okay, so it looks like the where was I? I'm trying to think now. Oh, back over here. So it says here 7406N. If we look on the parts list here, where's it gone? It says U8 is a 7406 or 7416, but obviously it looks like since this was done, they replaced it with a MOS equivalent. So in U8, which is here, it took me a little while to actually work out this here is an inverter for U8, and then this goes into the 6526 here. So it could well be that, okay, it's gone back for it. This inverter here has failed, which being that if we follow where we're going, we follow this up, we've got the serial bus here, and as just wait for that bit there to get down to the serial bus. Okay, so it's gone past it that time. So this seems to be related to this serial bus here, where the bits where it seems to be mostly hanging. I think it does hang on the user port as well. and again the user port on this pin here seems to go to pin 12, so somewhere it could be be round here on here with this U2 CI. So it's either this inverter or this CIA. So rather hoping the inverter. I had a little look around. This was based on, who was this? This was Tynemouth Software, and it's talking about the MOS 7707, which again is this chip here, is a MOS produced 7046 replacement. For some reason it seems to fail. So the 7406 and the 6526 have pins connected to the outside world on the rear connectors, so obviously back here. And you can get static or voltage differentials when things are plugged in when live. I don't remember doing any of that to this, and I'm positive it was the power supply that killed it. So you never know. Either the VIC was killed, which replaced. Oh, that's very warm. The VIC was replaced, as I said, which was killed by that. So maybe this died as well as part of it. So I did retrofit clamping dials across the pins. I have to look that up to find out what that means. Maybe I'll do that. Seems to be some diagrams bit here. I'm not quite sure. I think this is partially related to the VIC-20. And it looks like we've got some tests we can do, some pigs and pokes, so we can actually test the 6526. So we'd have to well, it says it often fails. And it says we can test some of the pins. If we go to 6526 and measure the output voltages on the IEC port, so I would say, I'm not sure what IEC means. Serial interface connector? No, hang on. What am I looking at? IEC? I have no idea. But we should be able to check some of these bits. You never know, you should be able to peek and poke some of the bits, and maybe we should be able to work out whether it's this chip at fault. So if I can get a oscilloscope on it, and then I can work out to see what's going on. Maybe I will be able to work this out, whether it's the CIA at fault. So I guess I can measure what's coming off the CIA, and whether the resultant inverter bit, I assume, if it's an inverter, I have no idea about electronics, that if it goes in one way, it should come out the opposite way. I have absolutely no idea. I assume that's what an inverter does. Anyway, we'll come back to that because it's getting late and I'm going to go to bed. So thanks for watching so far, and see if we can get the next bit, which will probably be in a couple of days' time after I've started making this video.